Okay, so we're going to look at interval notation for a minute and a few examples of solving inequalities with absolute values. So first of all, interval notation. We've seen like x is greater than 3, and we know that on a number line, this would be all the values starting at 3 and greater. And that isn't 4 necessarily, because there's like 3.1, 3.2, there's lots of numbers in between. So that's all of these. And we could also say greater than or equal to 3, and how that changes as we fill in that circle, because we want it to be equal to 3 and we want the 3 to be part of the solution. So there we go. Now, there are other forms of notation, and actually in calculus we use the other form. So I want you to look at these number lines, and you see that they start at 3, both of them, and they end at what we would say is like positive infinity way up here. And so interval notation for these, for this first one, in interval notation, or set notation, some call it. In set notation, we would say that this starts at 3 and ends at infinity. And we put these round brackets around it to mean that it does not include those numbers. So if it includes a number, we would put a square bracket. So it would look like this. Now, notice that I have a round bracket on the end where the infinity is, and that's because infinity is not the biggest number. It's the idea of a biggest number. Like I can always add 1, and then that's bigger than the infinity I wrote. So we never put a square bracket on an infinity. Okay, so what about other inequalities? What if we said x is less than or equal to 5? So less than or equal to 5, here's 5. We want equal, so color it in. And we would call this a closed interval when it's colored in. All right, we say this is closed. When it's not, this is open interval. And so in interval notation, this is minus infinity. So we said negative infinity to 5, and we would go like that. And then greater than 5. Empty circle, greater than would go this way. And here we would say 5, but not included, so round bracket. Whoops, I didn't mean greater. Let's start that again. I meant less than. There we go. And so we want to go from negative infinity to 5, but not included. Okay, so those are open intervals, and this one is closed on one end and open. And then if we look at different types, so let's say we wanted between -3 and 5. So we're going between -3 and 5. 5 is shaded in because we want to include the 5, but the 3 is not. So this is like a mixed interval, and we would say this goes between -3 and 5, and we would put a square bracket on there. Okay, so that's how that would be. And then what if we wanted something like x is less than 3, or x is greater than 6? Let's make one of them an equal. So less than 3, no equal sign, so an empty circle, and less. And greater than 6, so 4, 5, 6, color in the 6. And we want greater than or equal to 6. So how do we show this? Well, there's 2 pieces, so we actually show it in 2 pieces here. Let's just write the infinities on. Sometimes that helps people. So here we're going from negative infinity to 3, but not including the 3. And here we're going from 6, including the 6, so a square bracket, to infinity. And then what we put in the middle is what we call a union symbol in set theory. And you don't really need to remember the name, but it means or. Okay, so it's a set notation symbolizing or. Okay, and so that's how that would go. So I want you to try one. Let's suppose I have a number line here, and let's go suppose we had something like this. So just pause the video and take a guess. Try to write that down. There's two pieces, so you need two intervals. So the first one starts at 3, but not including 3, and ends at 4, and we want to include the 4. And then the other part, so union, it starts at 6 and it goes to infinity, and that's what it would look like. Okay, so that's interval notation. And so let's just put all the intervals together and solve a couple questions using interval notation. Okay, so let's think about this. So let's do some examples. And let's do the absolute value and inequality mixed, because those ones are usually the tricky ones for people. So let's say x minus 3 is less than 8. Okay, so what would this look like? So remember, absolute value has two possible answers. So step 1, let's say x minus 3 is equal to 8. That's like case 1. And case 2, x minus 3 is equal to negative 8. So let's solve these. Okay, so I get minus 5 and 11. And then I want so that's where they're equal to 8. And I know we don't want equal, but we want to see what works in this equation. So you change the sign to an equal sign and then put the numbers in question on a number line and give it a test. Test it out. Some number less than 5. Let's say negative 6, negative 7, negative 8. Let's do negative 10. That's easier to plug in. Something between negative 5 and 11. 1 maybe. 0. Let's plug 0 in. And bigger than 11, let's plug 20 in. I think that's easier to plug into something. And we're testing out to see what works. So my original equation is absolute value of x minus 3, and I want that to be less than 8. So let's see which interval. Is it less than 5, between negative 5 and 11, or greater than 11 that works in this original equation? So if we plug in the negative 10, I get negative 13. The absolute value of negative 13 is positive 13. Is that less than 8? No. So this one doesn't work. The next one is 0. 0 minus 3. What does that give me? 0 minus 3 is negative 3, which is 3. Is 3 less than 8? Yes. So this works. And what about 11? 11 minus 3? 11 minus 3 is 8. Oh, not 11. Sorry. I noticed I made a mistake because I got 8, and that's what we used to find the 11 was the 8. So 20. 20 minus 3 is 17. Absolute value of 17 is 17. Is that less than 8? No. So the interval that works is in between. So we would say between 5 and 11 works. There's no equal sign, so we could say that x is a number between negative 5 and 11, not including those. And the other notation, we would write like this. Okay, let's do a second example. Actually, what if we had the same example, but we put a different sign, like greater than 8? X minus 3 is greater than or equal to 8. Well, I already know my two cases. I already solved x minus 3 equals 8, and case 2 was x minus 3 is equal to negative 8. I already got the negative 5 and the 11, and I've actually already tested them on the number line. So on the number line, I know which ones are greater than 8 and which ones are less. In the middle, I had it was less than 8. So now we want greater. So this one won't count, but these two were greater than 8. I'm just looking up here. 13 is greater than 8 and 17 is greater than 8, but the middle piece isn't. So now our answer for this one will be negative infinity to -5, and I put an equal sign now. Do you see that? So we want this to be equal, so a square bracket. And then since these don't overlap, we say union, and we want to go 11 to positive infinity. It's two sections, and the way that we would word this in the other notation is like that. So you can do it one of two ways. Now, what if I just said x minus 3 absolute value is equal to 8? Well, we already solved that as well. There's no inequality, so nothing to check. We just say here x minus 3 equals 8, and we get 11. And x minus 3 equals -8, and we get -5. So for this one, the different way to write it. So what we have been doing is like just saying this is 11 or -5. And if we did want to write this in set notation, we actually just write it like this. X is an element of, and then we put a curly bracket, which means we're just going to have a list in here. And so anything in a curly bracket like that is, whoops. There. Anything in a curly bracket, this is a set called set braces. And anything in set braces are just like a list of numbers. Not even in any specific order. So I could have said -5 and 11 in curly brackets, and that just means those two numbers and nothing else. Okay, so that's how we would answer that question. Okay, so that's a little bit about notation and a few more examples. You can give those a try.